Alright, let's look at the homework 4.3, problem number 3. Alright, part A, we want to find the critical number of this function. Alright, so let's do that. Alright, take the derivative, so f prime of x is equal to, alright, so we have two things multiplied together, so we're going to apply the product rule. Then derivative of the first guy is 8x to the 7th power times the second guy, which is a quantity x minus 4 to the 7th power, plus x to the 8th multiplied by derivative of the second guy, so 7 quantity x minus 4 to the 6th power multiplied by derivative inside, which is 1 anyway, so I'm not going to write that down. Alright, then we're going to collect the common factor. So it looks like we have x to the 7th power, and you have 8 of those, so I'm going to take 7 of them. So you're going to get x to the 7th power. And also we have x minus 4 to the 6th power, so we have 6 of those here. So we have x minus 4 to the 6th power. Alright, then we have to collect the leftover terms. So we have 8 times x, so 8x, minus 8 times 4 is 32. Right, then we have plus 7x. Right, then this is going to be, we have x to the 7th power, x minus 4 to the 6th power, and then we have, let's see, 8x plus 7x, so it's a 15x minus 32. Alright, so if you set this guy equal to 0, we get critical numbers, x equals 0 and 4, and kind of a big number, 32 over 15. Alright, so we have that. So let's type it in. So 0 for 32 over 15. So I'm gonna put 0, smallest value 0, and I think 32 over 15 is the next one, and 4. Alright, I'm gonna go ahead and check this one. Alright, let's see, submit for testing. Alright, it came back. Looks like we got the part A correctly. Alright, so what does the second derivative test tell you about the behavior of f at the critical numbers? Alright, so we want to find the second derivative, so let's do that. Alright, so we want to take the second derivative, another derivative, so we have f double prime of x, right, is equal to, alright, so these are three things multiplied together, so derivative of the first guy, so 7x to the 6th power, and then times the next two, so you have x minus 4 to the 6th power, and then you have a 15x minus 32, right, and plus, right, leave the first guy alone and take the derivative of the middle guy, so 6 quantity x minus 4 to the 5th power, and leave the last guy alone, so 15x minus 32. Right, plus, right, then we have, let's see, leave the first guy alone, and then we have x minus 4 to the 6th power, right? Then take the derivative of that, so that would be just a 15. Right? Then let's collect the common factor. So it looks like you have x to the 6 here, and you have 7 of them and 7 of them. So you have x to the 6 is factored out. Right? Then you have, let's see, we have x minus 4 to the 5th, x to the 4, x minus 4 to the 5th, and x to the x minus 4 to the 5th. So we have x minus 4 to the 5th. Alright, and what else in common? Looks like that's about it. Alright, so it looks like that's it. So we have to collect the terms here. So I'm gonna just do this. So you have a 7, 15, x minus 32, right? And then you have you have another x minus 4, right? This is not fun. All right, then let's see. We have so we took care of this guy and that guy and that guy from the first term. That's everyone. And then from the second term, you have 6x, and then you have 15x minus 32, right? Then here we have 15x, x minus 4, right? So this is kind of crazy. So we have that, we took care of that, took care of that, took care of that, took care of that. Alright, so let's see, I want to simplify, but I'm gonna kind of stop here. Alright, then you can see that when x equals 0, second derivative is going to be 0, and if you plug in 4, second derivative equal to 0. So at 32 over 15, you're going to get something, right? So 32 over 15. So we just need to know the sign. So let's look at the f double prime of 32 over 15. All right. So let's do this. We have, right? So x to the 6th, so that's going to be positive. So we don't have to worry about this. All right. So you have 32 over 15 minus 4. So that will be negative to the 5th. So that will be negative. All right, then here, if you plug in 32 over 15 here, that's 0. That's 0. All right, then you have 15, 32 over 15, that's positive. But this guy is going to be negative, so you have a negative, right? So this is 0, 0, this is negative. So you have a positive times negative, so that will be positive, right? So we know that this is going to be positive, which tells you that by second derivative test, it's going to be a local minimum because the shape is going like this, and we're looking at the critical number there. All right, so I'm going to type in. So at 32 over 15, it's going to be a local minimum. All right, what does the first derivative test tell you when the second derivative test does not? Okay, so since at x equals 0 and x equals 4, we get derivative equal to second derivative equal to 0, which is inconclusive. So we have to look at the these guys separately, 0 and 4. So here, if you look at the critical number, so I'm gonna draw a number line. Right. So we have 0 here, and 32 over 15, and we have 4. Right. Then we look at the sign of the first derivative, so f prime. So let's see, if you put the negative value, so like we can try x equals -1. Right. So -1 here is going to be negative. Oops, negative there. Right, because to the 6th power, that's going to be positive. -1 here is going to be negative. So negative times positive times negative. So that's going to be positive here. Right. After 0, before 32 over 15, we can try x equals 1. Right. If you try x equals 1, then this is going to be positive. That's going to be positive. This is going to be negative. So you have a negative sign here. Right, and after 32 over 15 and 4, so x equals 3 would work. If you put 3, so that's positive, if you put 3, so you're going to get 45 minus positive, so everyone's positive, so you get a positive sign there. Right, positive sign there. Right, after 4, x equals say 5, so positive, positive, everyone's positive, so this is going to be, actually, so is that right? So this is going to be positive and positive, positive, so everyone's positive here. Right, so looks like we have at 0, increasing turns into decreasing, so it's going to be a local maximum, and at 4, neither. Right, so you have at 0, you have local maximum. At 4, it is neither. Right, so let's check the answer. Submit for testing. Alright, it came back and looks like we got all these guys correctly. Alright, that's it. I hope that this was clear.